we need to take a look at alternate exterior, alternate interior, and corresponding angles. And it happens in a very special situation. It's one where we have two parallel lines. Here we've got line H and line I. And when a third line cuts across the parallel lines, we call that a transversal line. Just a big word to say that it's crossing the parallel lines there. Now, there are 8 angles formed in this type of situation, and that's what makes it so special. We have two parallel lines, and then that transversal cuts across it, and these 8 angles are formed. Now, there are two basic types of angles in this situation. We have the inside angles that we call interior angles, and we have the outside angles that are called exterior angles. Okay, so let's see if you can identify these when I kind of change the scenario up a little bit. Can you find the interior angles? Hopefully you said C, D, E, and H. Can you find the exterior angles? Hopefully you said 1, 4, 2, and 3 because they're outside the parallel lines. Well, that's great, but now we need to talk about alternate interior angles and alternate exterior angles. First off, let's take a look at alternate interior angles. They are a set of angles. They are two angles, kind of like complementary and supplementary angles. They come in sets of 2. So if I said, hey, take a look at angle 3, well, what is its alternate interior angle? It has to be an interior angle, so it's got to be 4, 5, or 6. But the rules are this. One angle has to be at the top of the interior. The other angle has to be at the bottom of the interior. So it's got to be 5 or 6, since we're using 3 right there. It's got to be 5 or 6 will be its buddy. But then it's got to be on opposite sides of the transversal line. So since 6 is on the same side as 3 of this transversal line, we have to say, hey, 5 is an alternate interior angle to 3. Moving on, 4 would have an alternate interior angle with angle 6. And then alternate exterior angles are pretty much the exact same thing. Um, when we take a look at, let's just say angle 1, it's on the upper side of the exterior angle, so we have to come down here and then go to the opposite side of the transversal line, and we say angles 1 and 7 are alternate exterior angles. The same is happening with 2 and 8. They're on opposite sides of the transversal line. One's at the top, one's at the bottom. Now, there is one other thing that we need to remember, though. If H and I, if these two lines, H and I, are parallel, then alternate interior angles and alternate exterior angles are congruent. So if this is a 70-degree angle, its alternate exterior angle is 70 degrees also, and we can just know that. If angle 1 is 100 degrees, its alternate exterior angle of 7 is also 100 degrees. The same thing's true with the interior angles also. If angle 3 is 100 degrees, its alternate interior angle is also 100 degrees. And angle 4, if that one is 70 degrees, its alternate interior angle is also 70 degrees. It's very, very handy to know this property. Now, corresponding angles is the other thing that we need to go and examine. If you'll notice right here, angles 1, 2, 3, and 4, it's a pod of 4 angles. It's like two lines have crossed. Well, when we look at the situation of two parallel lines that are created by this transversal line, you have to understand that this same pod right here is identical. 5, 6, 7, and 8 is identical to 1, 2, 3, and 4. And so this is another idea of having sets to make corresponding angles. Angle 1 corresponds to its corresponding angle, for lack of a better word, 5, because it's in the same location. You can see that they're the same size here. Well, 2 would correspond to angle 6, and that means they're also congruent because these lines are parallel, and this transversal is creating the exact same scenario. 3 would correspond to 7, and 4 would correspond to 8. Now, let's take a look at this same scenario, and let's change a few things up here. I'm going to give you one angle measure, and I want you to find angles 2, 3, 4, 5, 6, 7, and 8. You can use any type of angle relationship that you want, but you can't use a protractor. Mainly because this is not accurate. I did not draw this to scale, And this is really not a 105-degree angle. I'm just telling you to pretend it is. So here we go. I can use the vertical angle property to know that this one's 105 degrees. I can know that this is a 75-degree angle because of the supplementary angle property. I can then know the angle 4 is 75 degrees because of the vertical angles. However, it's the corresponding angles that come in very handy. I can say alternate interior angles also. See how it's alternate interiors? If this is 75 degrees, this would also be 75 degrees. And then I could use supplementary angles here if I wanted to, or I could use alternate interior angles, or I could use corresponding. I mean, the options are endless. Um, in this situation, I am going to use corresponding. If this is the bottom right angle up here at the top, I know that angle 7 has to be 105 degrees also because they're corresponding angles. And the same thing is true right here as well. There's so many different ways that you can go and get this information. It's just a matter of understanding the angle properties and using it to your advantage. Remember though, sometimes you're stuck with only one way to get that angle measurement, so you can't just rely on just corresponding angles and supplementary angles. Maybe sometimes you need complementary, or maybe sometimes you need vertical, or maybe sometimes you really do need alternate exterior angles. You just never know what you're going to find. So make sure you do your homework, make sure that you understand these types of relationships, and suddenly this geometry will get more understandable.